Oh, hello. Hi, everybody. Can you hear me? Can you hear me, everyone? I don't think I connected the audio properly, but I think it's working now. Okay. Um, so you can um, so you can tell me where you are joining from. Okay. You can say where you're joining from and your name in the chat. Just checking to see. Okay. Just making sure everything is working. Sorry, this is the first time I'm using this, so I can imagine. All right, just I want to check. I want to check that everything is working. Okay. All right. I think I can start. Right. So we don't lose any time. If you are joining us, right? If you just join, write your name, the city where you are messaging us from. Put that in the chat because I want to get started with solving this some questions. Okay. So I'm going to actually do that now. I'll share some questions. Okay. So I'm going to just let's fix that. Okay, we can bring back the banner. I'm just going to, I want to load up the slide again. Okay, hold on, let me sort this out. Okay, I have to redo the whole thing again. Okay, so let's go. Alright, hold on, I have to close the whole thing. Oh, I think I had it open for a second, so I have to do it again. Oh dear. Okay, alright, so, add this. Okay, I think I have it. Give me a second to okay. So I'm streaming natively with OBS. So um that's why everything is crazy. Okay. Now you can't see me. Okay. Um I think I'm just going to all right. You know what? We can manage. Okay. We can definitely manage. Okay. So a few questions that I want to get started with. The very first question is this question. So they're all past questions, and I attach the dates so that they all make sense. So it says, what are the values of x, y, and z respectively in the following equation? And then we have an equation with manganese oxide and some amount of moles that is represented with x here. right? So you notice that it's represented with X, okay? And X hydrochloric acid, and that gives you manganese chloride with Y water and Z chlorine. Obviously, you can see that you're just supposed to balance this equation, okay? Now I'll do it very quickly. So we just have to find X, Y, and Z, okay? So if you look, we have two chlorine, right? And we also have two hydrogen here, okay? So which means if we had to balance out this equation, X will have to be 2, rather X will have to be 4. It's going to be 4 because if we balance this as 4, now we get 4 hydrogen, right, which makes sense because then we can balance Y as 2 to make 4 hydrogen. Now notice that would make 2 oxygen here, but we're good because we have 2 oxygen here. And the 4 will make 4 chlorine here, but that's fine. We can just make Z a 2. So our answer is 4, 2, and 2. Okay, to balance the equation. 4 for X, Y is 2, right? And then Z is 2. That was a very simple question. Here's another question with with balancing equations again. This time around, we have X amount of ammonia in grams plus Y amount of chlorine, also in grams, will give you Z amount of hydrochloric acid and nitrogen gas. Again, we have to find the values of X, Y, and Z. Okay? So again, please, if you're joining, you can send a message in the chat. So let's find the value of X, Y, and Z. So we have X, Y, and Z. So for us to balance the equation, when we try to find X, you have to look. So X will be a multiplier for the nitrogen and the hydrogen here, right? So if you think about that, you can see how many nitrogens we have here. We have 2. That already tells you that X would likely be a 2. Now it's okay if you write a value and then you change your mind. That's perfectly fine, okay? So we have X at 2. So we have to find Y. So Y, so let's see. Y would be a multiplier to this chlorine, right? Um, so, but we have to pay attention because Y would affect Z, right? We have 2 chlorine, right? But here Z, we have no chlorine, right? So we have to put an amount for the chlorine. But we also have to pay attention to the hydrogen. And if you remember from here, hydrogen is 3. So that tells us that Y would be likely 3, right? Because it's Y, if Y is 3, then we'll have 6 chlorine, right? But if we have 6 chlorine, right, we need to balance this, right? And of course, we can make Z a 6. Okay? So that balances everything out. So we have, if we have 2, so we have 2 nitrogen, which is balanced, 6 hydrogen, which is also balanced because remember Z is a 6, so the hydrogen is balanced. Then we have Y. If Y is a 3, that makes 6 chlorine, which makes both the chlorine balanced. And the nitrogen is of course balanced. So it's asking which of these have the same um, molecular mass. So which of the following pair of components have the same molecular mass? And we're giving the relative atomic masses for hydrogen, carbon, and oxygen. Okay. This is a very straightforward question. You do have to know, however, what the formulas for ethane, ethine, right, CO2, right? You have to know what these are. And even ethane, I think there is ethane. Yes, there's ethane as an option for B. So ethane is C2H6. Okay? Whenever you have the eth um, suffix in prefix rather in front, you should know that you have 2 carbon atoms. Okay, so which will make ethane C2H4. Okay, ethine, and of course carbon dioxide. I wrote carbon dioxide already, so that's carbon dioxide. Okay, So if we find the molecular mass for ethene, that's going to be, so ethene, which is C2H4, is going to be 12 times 2 plus 4 times 1. That gives us 12, sorry, 24, right? Plus 4 times 1 is 4, right? So if we add that together, that gives us 28. Okay? So we have ethene as 28. Then we have ethyne, okay? So ethyne would be, so carbon is 12 times 2 plus 2 times 1. That would be 2 times, 12 times 2 is definitely 24 plus 2, that's 26. And then we have CO2, right? That's 12 plus. Now, oxygen is 16, right? Times 2 is 32. That gives us 44. By the way, all of these are, the masses are always in grams. And then we have ethane, which is C2H6. Again, that's 24 plus 6, which is 30. Okay, so let's see. Hmm. Which have the same molecular mass. So we see that carbon dioxide. Oh, we have. Oh, it actually says. Oh, it says there's carbon 2 oxide and carbon 4 oxide. So I have to clarify. This is carbon 4. You know what? I'm just going to write. I'm just going to write a 4. Okay. Carbon 2 oxide would be CO. So this is carbon 2 oxide. Okay. And I can squeeze in carbon 2 oxide here. That would be the mass would be carbon is 12 plus oxygen, which is 16, that gives us 28. So you see, I have 28 grams for um, ethene and carbon 2 oxide. So that would be our answer. Carbon 2 oxide and ethene would have a relative molecular mass of 28 grams. Okay? Very straightforward question. And this is asking what is the percentage by mass of hydrogen in this compound, okay? And so we have to ask ourselves how many hydrogen, because that's the compound that we're looking for, right? How many hydrogen are we looking for? So you know, if you look, you have 1 and 3 hydrogens. So that makes, plus the hydrogen, that makes 4 atoms of hydrogen, right? And if that's 4 atoms of hydrogen, okay, so that's going to be 4 times 1, right? Which is going to be 4. So I should have said 3 plus 1. This is 3, this is 1 hydrogen, and that's going to be 4. Okay? So if we have that as 4 times 1, so which means our total mass of hydrogen here is 4 grams. So we're going to put that as a fraction over 60, which is the relative molecular mass of the compound times 100 over 1. Right? And that's very straightforward. So you can punch this in the calculator. You can cancel out the zeros. You can do 2, and this is 3. So you're going to have 20 over 3, which will be 6.66. It's a repeating decimal percent. So you can see an approximation here. So that will be your answer. Okay. Right. Now we have another question on ratios. We have another question of ratios. It says the ratio of carbon atoms to hydrogen atoms in a hydrocarbon is this, right? So they gave us the ratio. So if I should put this in a table, just so that it's easy to visualize, okay, 1 and 2, right? And they did tell us that the molecular mass is 56, right? So if this is 56, remember, carbon, the relative atomic mass is 12, hydrogen, relative atomic mass is 1, right? So, but we have 2 of it, so it's going to be times 2, so that's 2. So if we add those together, we have 14, right? Right, so we have 14. So if we have 14, we know that the number of moles will always be equal to the entire mass divided by 14, which would be, if you divide this, I believe you would get 2, right? 14, you get 4 rather. So we have 4, okay? So which means that our number of moles is 4. So we can easily get our molecular formula. We just have to multiply it by the number of moles here. So we have CH2. By the way, I have CH2 because hydrogen has a 2, right? If I multiply that by 4, okay, you are going to have C4H. 4 times 2 is 8. Okay, C4H8. That looks like option C. Okay, so I'm moving very quickly. I'm just going to go again. Oh, so the sound is low. Oh, okay. Adeyemi, hi. I'm just going to see if I can increase the volume on my end. I don't think I can do that. Maybe turn up the volume on your own device, okay? Maybe turn up the volume on your own device. Let me see. Because here it says that the volume, the audio captures is fine. So maybe turn up the volume on your own device, okay? Also, I haven't been paying attention to, um, okay, so I didn't know that I was not on the screen, so you can see me, but I'm just going to make, make it very small, right, so that I don't block the question. So we'll just move to question 37, right? It says, what is the empirical formula? Now, there's lots of empirical formula questions we'll be doing today, okay? And it's for a hydrocarbon, so that's great. A hydrocarbon would be a compound with just carbon and hydrogen, okay? So if it has just carbon and hydrogen, we can put the masses, the number of moles, I should say, because they were given to us. It told us that it's 0.16 moles, okay? 0.160 moles for carbon and 0.640 moles for hydrogen. Now, because they've already given us n, which is the number of moles, we can just go ahead and find the simplest ratio by dividing by the smallest value, okay? So if we divide by the smallest value, this will give us 1, and this will give us 4, okay? So we now have 1 for carbon and 4. So we have our empirical formula C1H4, which of course you know is CH4. So that looks like option D. So empirical formula is straightforward. Um, Remember, if you wanted to get your molecular formula, we'll have to multiply it. So I would show you once we get to a question like that. Let's just go to question 38. It says, an element Q, right? It has or contains 69% of um, different versions of Q, right? Where we have Q63 and 31% of Q65, and it's asking us for the relative atomic mass. Remember, the relative atomic mass is an average, right, of the different isotopes of an element. So we can do this very quickly. If we have 69% of 63, we can just multiply 69 times 63, okay? We can add that to, we have 31%, okay? So that's 31 times 65, okay? And we can divide all of that, right, by the total, which is 100%, okay? So if you multiply this, so I've multiplied it, I have 4,347 plus, this is 2015 divided by 100. And so if we divide this, right, we get 63.62. Okay? So we can approximate that to 63.6. So that would be our relative atomic mass. So if you're given different isotopes, right, of so different isotopes, in this case here we have Q, just make sure you multiply the amount, right, the abundance by, you know, the atomic number, right, or rather the mass number. Do the same thing again here, and then you get your answers. And if you find the average, right, you should have your relative atomic mass. Okay. I'm just checking with the chat. Okay, okay, yes, so use earphones. Okay, fine, you can use your earphones. Okay, And then I will leave the stream up so that in case we want to come back to watch it. Okay, so we're on question 39. So for question 39, it says 60 grams of M, so the compound is M, right? And it combines with 24 grams of oxygen. Again, they're asking us for the empirical formula of the oxide, because the oxide will just mean that it should be M with oxygen, right? So I like to use my tables anytime I see a question on empirical formula. Okay, so you see M and you see O, right? So they told us that the number of moles, right? So first of all, we have to get the number of moles, I should say, for M. So I will just do this at the top. So the number of moles for M, I'm just going to write NM, number of moles for M, okay? Let's see. Normally you get your number of moles by calculating the reacting mass, okay? Reacting mass divided by the molar mass, right? So we can keep this very simple. So we can see that the number of moles, right, here for oxygen, so we have 60 grams, 24 grams for oxygen, right, and 60 grams for magnesium. So if we have this as 60, right, over, we can divide this by 120, we have 0.5, right? Meanwhile, if we look, the number of moles for oxygen is 24, right? So if we divide the number of moles for oxygen here, which will be 24, divided by, so we're going to divide this by 16, right? And we're going to have 1.5. So obviously, you should know that your reacting mass, right, for M here, we're using 120. So that's why we have 0.5. So we can now put in our 0.5, okay, and 1.5. Now, I'm sure you're wondering why I use 120 here. That is because, if you know how to, if you know anything about writing formulas, oxygen has an oxidation number of 2. So they would swap out, right? So you should have M with 2, right? That's why this is doubled here. Okay, so we would find the smallest ratio, okay? And if we find the smallest ratio, this will be 1. 1.5 divided by 0.5 will be 3. Okay? So which means our empirical formula, which is what they asked us, will be MO3. So that's our answer. All right, so we can go to the next question. So I'm going to just check in the chat, just in case we have new people who are joining. Please, when you join, you have a question, you can put it in the chat, okay? All right. Okay, let's move to question 40. Okay, 23 minutes so far. Let's see if we can wrap this up in 1 hour. So a hydrogen chloride gas reacts with oxygen gas to yield water and chlorine gas. Right. Now the ratio of hydrogen chloride to the water is, obviously you already know that you have to, when they're asking you for mole ratio, you have to write the chemical equation. So let's see what is reacting. We have hydrochloric acid, okay, and it reacts with oxygen. Okay, so we know this is reacting with oxygen, and that's going to give us um, water, right, and chlorine gas. That's what they told us. All we have to do is to just balance this out. Okay. So we can see that we have 2 oxygen, we have 1 oxygen here. So if we try to balance the oxygen, we have 4, right? 4 hydrogen, that is. So if we balance this, but the chlorine becomes 4, so we can just easily remedy that by putting a 2 here. Okay, so everything is balanced. So if we now have 4 molecules of hydrochloric acid reacting with 1 mole of oxygen to give 2 moles of this and 2 moles of chlorine. Okay, so if we look at the mole ratio of hydrochloric acid to water, what we have now is 4 to water is 2, right? Don't forget to simplify this to 2 to 1. Okay, so our ratio is 2 to 1. That's all they asked us, the mole ratio, which is 2 to 1. Again, don't forget, if you're writing mole, if you're trying to calculate mole ratio, make sure you write the equation, okay, and then balance it. That would really help you with finding the mole ratio. Okay, now so we have some theory questions here, okay. The first one, The first question here asked us to write a balanced equation to illustrate the reaction of aluminium oxide with hydrochloric acid, another equation with sodium hydroxide. Okay, so if if you know anything about aluminium oxide, it's amphoteric, right? So it should behave sort of like an acid if it's reacting with a very strong base, and should behave like a base if it's reacting with a very strong acid. So we can write the equation, okay? So let's first of all react it with hydrochloric acid. Remember, so it's amphoteric, so you should be expecting to have a salt, and that salt is aluminium chloride. Okay. Now because aluminium has an oxidation number of 3, that's why chlorine has 3 here. Okay. And then of course we should expect to produce water. Now all that is left is to balance this reaction, right? So this should be pretty straightforward. Let's try balancing the aluminium first, right? That now gives us 6 chlorine, right? So if we want to balance the chlorine, we have to put 6. Okay, and that now gives us 6 hydrogen, so we have to fix that. We have 3 here, and then the oxygen is balanced. So that will be for the first equation. Okay. Now for the second equation, we have to react it with a base. Again, we expect to get the salt. So react with sodium hydroxide, and that will give us, if we so again, like I said, you get a base, but a salt rather, but it's a complex salt. It's sodium, aluminum hydroxide like this with 4, right? And um and so that's what you expect to get. Okay, so we can balance this. So let's see, what do we need to balance? um we have to balance, oh, and then of course I forgot to put water. So if we have to balance this, so let's see, we definitely need to balance with the 3. Okay, that balances the oxygen, makes the hydrogen 6. So let's see how many hydrogen we have here. We have 6 hydrogen here, so we'll balance that as well. Also, if we balance here with because we have to be very careful. Hold on. So something else I'm going to change. Okay, I'll just maybe stroke this out. Something else I'm going to change is that I'm going to try to write this equation, but this time around with um, water, okay, so that I will have my complex salt. That makes more sense. Okay, all right, that makes more sense. This will be easier to balance. So if we have 2 here, we can balance this, and 3 here. I'm just trying to balance it very quickly. So you can see we have sodium, we have aluminium, right? Aluminium is 2, so sodium, oh, okay, we have to balance the sodium here too with 2. Okay, what else? Don't forget this has 4. So I think our equation is balanced. Okay, this one was a tough one, but I think with the hydrochloric acid was very straightforward. Okay, okay. So another question again with writing an equation. So this time around, it wants us to react zinc powder. Okay, so that's just zinc powder will just be zinc, right? So we're going to write how many equations? 2. Okay, let's have a go. So we have zinc. We're going to react it with, it says dilute tetraoxosulfate 6 acid. So H2SO4. So of course you already know when a metal reacts with a strong acid, what happens is you get a salt and the hydrogen gas is released. Okay. And then if we have with concentrated tetraoxosulfate 6 acid, okay, so this was dilute. Now if when you're reacting with um concentrated, so I just put CONC here to tell you that that's concentrated. You still have your salt, right? You have water this time around, right? And then you have the sulfur dioxide gas. This is gaseous. Okay. So take note of that. This is what you get when you react with a concentrated acid. This is for a dilute acid. Okay. Now, of course, you should go ahead and you can go ahead and balance that. Balance the equation. Okay. Hi, Ridwan. Welcome. Welcome, Ridwan, watching from Kogi State. Okay. At about the 45 minutes mark, I would start to give us I'll give us a quiz that we need to do. All right. Okay. That's one simple. You just ask us for the IUPAC name. Okay. Um, when you are writing the IUPAC name, you have to um you have to pay attention to the oxidation numbers because that's very important for calling out the compound. So, for example, you call out the metal first. So this is copper. Okay, then this group of atoms here, SO4, right, is together it's called sulfate C. So copper tetra. So you start from the oxygen tetraoxo sulfate 6. The 6 was the oxidation number I was telling you earlier, right? So copper tetraoxo sulfate 6. Now, if this is it does have some additional water crystals attached to it. So we say pentahydrate. Okay, penta. This should be joined together. I don't have space, that's why I'm writing it as pentahydrate. Okay, copper 2, copper tetraoxo, copper 2. I missed the 2. Okay, again, I told you you have to pay attention to the oxidation number. The 2 is because the oxidation number of copper is 2 here. So it's copper 2 tetraoxo sulfate 6 pentahydrate. Okay. So the same thing with the other compounds. Maybe I should give us the other compounds to try. They're very simple. So this was the first one. The second one is CaCO3. So you have your CO3 ion group here to help you call out that compound. Then you have KMNO4. The rules is still the same, right? Make sure you mention the name of the metal first, followed by the name of the ion group behind it. So I'm just going to look at the chart to see who's going to give me answers for question 2 and 3. The IUPAC name of those compounds. Okay, the IUPAC name of those compounds. Calcium triazocarbonate 4 and oh sorry, I accidentally called out the answer. So the first one is calcium triazocarbonate 4. Okay, so but the last one you can give me the answer. So since I already blotted out the answer, might as well write it. Calcium trioxo because there's 3 oxygen. Just underline that. Trioxo carbonate 4. Okay. That's because the oxidation number there, carbon is 4. Now I'm just underlining this to sort of break the sentence. That doesn't mean you should underline yours when you are writing. Okay. So yes. So can we give me the answer for number 3? Potassium tetraoxo manganate 7. Okay. Thank you. Okay, potassium tetraoxo manganate 7. Oh, it's manganate 6. Okay. Is it manganate 6 or manganate 7? I'm just going to wait a little bit before I say out the answer. Is it manganate 6 or manganate 7? Don't forget, if you are just joining us, you can please write your name in the chat. Okay, and where you are joining us from. Okay. So I would reveal the answer later. Just want to give other people a chance to attempt the question. So I'm going to put quiz and then come back to it. Okay. So everybody can have a chance to attempt the question. Maybe I can type it in the chat. So I'll say quiz question. Okay, what is the IUPAC name for potassium? Okay. Okay, you amended your answer. And just put okay. Hi John from Ibadan. You're welcome. So I put the quiz question in the chat, okay, because I want as many people to attempt it as possible. Then I'll come back and reveal the answer. Okay, so the quiz question is in the chat. I think we can move on. Okay. So I have some more IUPAC names. Okay. You know what? Maybe we should attempt these as well. So we have NACLO. Okay. The second one is CuSO4. We talked about SO4 ionic group here in this on this call. Oh, and it has so I'm going to write that again. I forgot to add the attached water. So H2O. So I'll just put an X here. So we can provide the answers for Na. Okay, NaClO. Okay, we don't want to say the name, and CuSO4 5H2O. That's three questions I've given so far. Do I need to put it in the chat? Okay, maybe I should. Should put it in the chat. So, oh yes, I can just copy it and put it in the chat. Okay. So, some more questions in the chat, so we can continue. You can attempt the questions in the chat. Okay. Now, the next is another chemical equation. It says we should write a chemical equation to show the effect of heat on each of the following compounds. Okay. And they gave us a bunch of compounds that were supposed to show how heat affects them. Okay. The first compound here is K. Hold on, let me initialize the pen. So that's KNO3. Okay. So we're going to add heat to this compound. Now, I don't know if we know anything about when you add heat to a certain compound, right? But you see this particular compound, when you apply heat to it, okay, just give me a second. So when you apply heat to this compound, you can call it potassium nitrate because of the 3 oxygen, okay? Or potassium trioxynitrate 5, right? When you apply heat to it, what happens is that you would reduce the compound, okay? So it loses one um, one atom of oxygen, right? And so it becomes potassium nitrite, right? With I, so nitrite, okay? And then by the time it loses it, that oxygen is released as a gas, okay? So very straightforward. Same thing with silver. You can call this common. This compound is commonly called silver nitrate or silver trioxynitrate 5, okay? You can, if you are following, you can guess that it's a similar reaction that happens here, right? In fact, when you react this, what you have is you have silver, okay, the silver itself as a residue. So what you have is silver plus NO2 plus oxygen. Okay? Because these will be gases. The actual silver is a residue, so that's solid. Okay, and finally you have copper. I think I gave this as a question. Copper triazocarbonate, triazocarbonate 4. Okay, or just you can commonly just call the compound copper carbonate. Okay, but the IUPAC name will be copper triazocarbonate 4. Okay, so again, if you add heat to it, right, the compound again is reduced. Right, so the compound again is reduced. Okay, so it is reduced to give you copper oxide. So copper oxide, right, and then oxygen gas. You can go ahead and balance the reactions, okay? That's fine. I'm just going to actually move very quickly. I want to just note which ones are solid and which ones are residues, okay? And then which ones are gases. The question is just that straightforward. Question 6 says, consider the following, right? And it gave us some compounds. It says sodium, lead-2 iodide, hydrogen, magnesium, and then oxygen. It says which corresponds to the formula AB2. Well, this is very easy, right? Because lead iodide, right? You can write lead iodide like this. Lead has an oxidation number of 2, so lead iodide is the one that corresponds to this formula. where A is the metal and B would be the iodide attached. So that question was straightforward. Um, we were at 2:40. I said by 2:45 we'll take the quiz. Okay. Now question 7 says, ion completely reacted with dilute hydrochloric acid, right? Remember I told you when metals react with hydrochloric dilute acids, they liberate the hydrogen, right, from the acid. So it says we should write an equation for the reaction. That will be very straightforward, right? So all we have to do is to write that, hey, we have ion reacting with hydrochloric acid, and that will give us ion chloride and of course the hydrogen gas. Now it's going to be ion chloride and ion 2 chloride like this. So because the next question is asking us for some stoichiometry calculations, it's asking us for hey, if 3.0 grams of iron is reacted with 5.0 cm cube of 2.20 mole per dm cube of hydrochloric acid, it's asking us to find the relative atomic mass. What you have to do is you have to balance the equation, which is very straightforward because you can balance here with 2, right? And I think everywhere is good, okay? So it's balanced. First thing I'm going to do before I start calculating is I'm going to change this, which you should always do, from cm cube. Let's change this to dm cube. So of course you just multiply that by 1,000, so you have 0.05, right? So that will be in dm cube, okay? So then we have that ready. The next equation that we're going to use is that N is equal to CV. The reason why I'm saying that is because I can see that we have 2.20. This will be the concentration, right? So that will be our C, okay? And then we don't have V, if you notice, it didn't give us, oh yes, we do have V. Never mind. We have the volume here. So our number of moles would be 2.2 times 0.05. So let me just punch that in my calculator. I have 0.11 moles. Okay, all right. So 0.11 moles. So what else are we looking for? They asked us if this amount in grams of iron reacted with this amount of hydrochloric acid. Calculate the relative atomic mass of the metal, right? That's what they're asking. Now remember, if you look at the equation, 1 mole of iron 1 mole of iron reacts with 2 moles of hydrochloric acid. So I'll just write Fe for iron and HCl. So I don't know if you noticed that, right? So if 1 mole is reacting with 2 moles of the acid, so we're going to ask ourselves, how many moles is going to react with, so we're going to ask ourselves, how many moles of iron, right, we need to react here? So we're going to do 0.01 so 0.011, the number of moles we have, divided by 2. And if we divide that, we're going to have 0.0, let me punch that in again. We divide 0.01, right? We're going to have 0.055, okay? So that's our number of moles. Now, finally, if we now have our number of moles that is actually reacting here, we can now put this to get our relative atomic mass. Because I'm out of space at the bottom, I'm just going to go to the top. Remember, your relative atomic mass is equal to your reacting mass. Reacting mass over your molar mass. Molar mass. Okay. So our reacting mass, they already told us that is 3.08. Okay, and then our molar mass. We have our molar mass. Oh, we're looking for the molar mass, obviously. So, but we do know we have the number of moles, so we can divide it by the number of moles. So if we divide this, we should have 56. Okay. Should have said here your number of moles. There's a mistake here. N number of moles is equal to the reacting mass. That's why to get the molar mass, we divided our reacting mass by a number of moles, which gave us this gave us not 5.6 but actually 56. Okay, so 56 grams. So a bunch of things that you should note here when you are calculating. First of all, make sure that if you have any value in cm cube, make sure that it's in dm cube. That's very important. Okay. And if you have if you see a value that looks like this 2.2 mole per dm cube, that's your concentration, what I have as C here. And I multiplied it by V, right? What do I mean by V? V is volume, which is the one that we just calculated here. So if you have 2.2 times 0.5, that's how I got the number of moles. Okay, this is the amount of moles that is reacting. Now remember, we have 2 moles that was reacting in the actual equation. That's why at 0.01, right, I divided it by 2 to have half of that, which is 0.05. So if your number of moles, right, is your reacting mass divided by your molar mass, which means if you divide your reacting mass by your number of moles, which is what I did here, you should get back your molar mass, right? Which is what I'm calling molar mass, obviously, the relative atomic mass that they're asking you for, RAM, right? That's 56 grams. I just want to check the charts just in case some of these questions need clarification. Okay. Oh, I've not been looking at the chat. So quiz, what is okay? I put the quiz. Oh, thank you, Adeyemi. Thank you, Ridwan. Sodium oxochlorate. Okay. So most of us got is correct. By the way, it's manganate 6. Okay, great. So I'm going to note down everybody who gave me answers. Okay. By the way, I really want to thank everybody for participating. Okay. Now I'm going to give us this question again, right, for us to work on, because I worked on a similar question. Well, in that question we had um, 2 isotopes, just as we have here. The element is called Z. You can see the different variations of it, right? And it's asking us to calculate the relative atomic mass. I already discussed how to calculate this. I told you to multiply the abundance of the element, right, by the mass number, and then find the average, right? By average, I mean divide it by the total. So I'm just looking in the chat. Is there any of us that understands how to solve this question? I want to know if I should go ahead and solve it. Okay. I want to know if I should go ahead and solve this question, or if we know what to do. Do we know what to do, or I should go ahead and solve the question? Okay, maybe I should go ahead and solve this question. Okay, but like I said, very straightforward. They told us that the okay, so I'm going to work it out here, but I do need to put some information here. They told us that this isotope, this particular one, right? They told us that it is 75% abundant, which would mean that the one that is 109, that has a mass number of 109, right, would be 25%. It should only have 100%. Okay? So we already know what to do. I told you mass number times the abundance. So we have times the abundance, right, plus, I'll do the other one, 109 times 25. I'm going to divide this by, now in total we have 100%, right? Because we're given certain percentage. So if you punch this in the calculator, you should be able to get your answer. Okay? Let me actually just do that very quickly. So 107. So 107 times 75. Okay. So I got 8,100 plus 109 times 25. That's 2,000. That's what I got, 2,725. So I'm going to add those together, and I'm going to just divide it by 100 here. I have to do that again. 8,000 plus 2,725. Okay, I'm going to divide that by 100. Okay, and I have 108.25. Okay, and there you go. That's your answer. Very straightforward. That's your answer. That's straightforward. Okay. So now this is a question that is asked. This question is asking us explain briefly why the relative atomic mass of chlorine is not a whole number. If you know, the relative atomic mass of chlorine is 35.5. Okay, 35.5. And the reason that is very simple because the relative atomic mass is simply the average of all the isotopes of chlorine, right? So if you find the average of both isotopes, you have 35.5, which is what we've been doing, what we did in this question. We found the average, right? That's why usually they're always in not whole numbers, they're always in decimals. Okay. Um, Now I think that I'm going to answer one more question, right? So they did give us a question that so this is baking soda, NaOH. Can stop after this. This is baking soda, and they told us that this baking soda. Oops, sorry, baking soda. That's what I was going to write down. And they said baking soda is reacting with hydrochloric acid, right? You can see you get a salt, water, and CO2, right? Very straightforward. Now they're asking us to calculate the mass of baking soda that will produce 10 grams of CO2. Very straightforward question, but I do need to write the reaction again. So we have baking soda, okay, that's solid, reacting with hydrochloric acid to give us sodium chloride plus water plus carbon dioxide. Okay, so if you look, the baking soda and the hydrochloric acid, right, is a one-on-one ratio, right? So if we have both of them as a one-on-one ratio. In fact, if you look, all of them, one mole of one, sorry, one mole is produced in each case of the compound, right? So, and if you remember, we're asked to calculate the mass of baking soda that will produce CO2. So we're actually interested in how much moles of this is produced. So we can find the molar mass of CO2 very simply by doing this. We have 16 times 2, that's 32, which will be 44 grams, right? Very simple. And then we can do the relative molecular mass of baking soda. Okay. So they already gave you all the values here, okay? So I'll just punch this in here and I have 84 grams. So because it's relative molecular mass, it's usually gram per mole. Okay. So we have all the relative molecular masses. So it's very straightforward. So which means that for if I'm just going to put CO2 here and I'm going to put what's the other compound? The baking soda here. If 44 grams gives us 84, and it says 10 grams. We're actually just using 10 grams. What will it give us? So I'll just continue solving here. So we have 44x is equal to 840. So which means x is equal to 840 divided by 44. Okay. And I think if you punch that in, you have, just want to check again, 840 divided by 44. 840 divided by 44 divided by 44, and I have 19.09. Okay, I have 19.09 grams. Of course, I just approximated, but 19.09 grams. I really wanted us to stop at number 10, but this was a good place. This is a good place to actually stop. Okay, so thank you to everybody who actually did send in comments. Thank you so much. Um, so of course, I would take notes of the comments that I got. Okay, so thank you, Ridwan. Thank you, Adeyemi. Am I missing any other person? So thank you so much. Okay, so I'll just go ahead and end the live stream here. Right. So hopefully we can see each other again next Monday. All right.